Welcome to Brainbox. In present session, we are going to discuss about the reaction of metals with acids. Right. So previously we discussed about the reactivity of metals with oxygen and even with the water which is present in the atmosphere. Right. In the similar manner, let us see about the reactivity of metals with acids. So for example, I will take few metals like a more reactive metals. If at all we have taken this, the acid what we have taken is HCl, so that the reaction is just going to be the replacement of hydrogen with sodium and it releases hydrogen gas. And to balance this, I'm just going to take the 2 moles. And in this, the very important thing what you need to understand is the metal what we have used is more reactive, and more reactive metals replace hydrogen from acids, right? So this reaction can happen only if the given metal is more reactive than hydrogen. The same reaction we can even take for another metal like Zn. So I'll take Zn plus HCl, and see the valency of zinc here is 2, hence it will replace at a time 2 hydrogen atoms, hence the compound what we get here is ZnCl2 and with the release of hydrogen. Okay, so from this overall, what do you understand? That acids, with acids any metal can react. The condition is the metal must be more reactive than hydrogen, and such metal will replace the hydrogen from its compound so that it forms a corresponding compound. See, for example, we have used hydrogen chloride. Then the metal obtained, means the compound obtained will be the metal chloride. Similarly, we have, if at all we have used hydrogen bromide. So for that, I will take one more example. So aluminium, if at all it is treated with HBr. Okay, and in this case, I'm going to take 3, that is because to match with the valency of aluminium valency is 3, so we are going to get a compound AlCl3, aluminium trichloride, means it's bromine here, so we are going to get aluminium bromide. And again, the release of hydrogen is every time common. Okay, and we will take it like this. Okay, so in all these cases, the common thing is what? Whichever the acid is taken, from that hydrogen place is occupied by the metal. Okay, and occupying the place of hydrogen, it gives a compound whichever the other ion is there. If the other ion is chlorine, you will get the chloride. Other ion is bromine, you will get the bromide. So it always, whatever the compound we get, completely depends upon the opposite ion to that of hydrogen what we have taken. Right, and this one, another condition is that the metal must be more reactive. Means to understand all this, what you need to understand is the metal reactivity series. In the sense, the order of arrangement of all the elements in their decreasing order of reactivity. Right, so I'm going to write here about the metal reactivity series. Okay, so it is just the decreasing order of the elements in their reactivity. Okay, so the decreasing order of reactivity of elements, if at all we see, most frequently used metals I'm selecting here. So potassium is supposed to be the most reactive. After that, sodium, and then calcium and magnesium and aluminium, zinc. Like continuation will take, it is like iron and tin and lead. Right, so these are all the elements in their decreasing order of reactivity. In the sense, what do you understand from this? Potassium is more reactive than sodium, sodium is more reactive than calcium, like that. It is the decreasing order of reactivity of metals. And now, this, to understand about this reaction, means whether the given metal reacts with hydrogen or react with acid or not. To understand this, you need to know which are all the metals which are present before hydrogen in the metal reactivity series. right? So here is your place of hydrogen, in the sense before this whatever may be the metal is present, all these metals can react with the acids and replace them to release hydrogen. Okay, so reactivity is one indication whether the given metal can react with the acid or not, can show the displacement reaction or not. To understand this, one proof or one indication is that the release of hydrogen. So the release of hydrogen when the given metal reacts with the acid indicates that the metal is more reactive than hydrogen. Now after this, its continuation, if at all we see, it is copper, mercury, silver, gold, and then platinum. Okay, now these metals are less reactive than hydrogen. And its meaning is, if at all these metals are made to react with hydrogen, sometimes there is no reaction, and even if reaction occurs, hydrogen will not be released. For example, we'll take about the reactivity of copper with HCl. There is no reaction actually. Okay, and the same copper, if at all it is treated with HNO3, it shows the reaction. Okay, and it shows reaction, and the gases released will be either NO or NO2. Means here it is not the displacement reaction, means the metal is not more reactive than hydrogen, hence it cannot replace the hydrogen like these metals and cannot release the hydrogen. And here the reaction is happening because HNO3 is oxidizing agent. Okay, why this reaction is happening? This reaction is not happening because of reactivity of metal. This reaction is happening only because of reactivity of nitric acid, because nitric acid is a good oxidizing agent. It oxidizes the copper to its compounds, right? And it itself is reduced. So how it is reduced? It is reduced to nitric oxide or nitrogen dioxide. Right? And similarly, if at all we have taken any other metals, most of the time copper with H2SO4. Here again, no reaction. Okay, so why? Because copper is less reactive than hydrogen, hence it cannot replace the hydrogen from its compounds. So, metals, which metals? Any metals which are present here, means which are present before hydrogen in the metal reactivity series, can give this type of reaction to release hydrogen. Okay, and all those metals which are present after hydrogen in the metal reactivity series cannot give this reaction. Got it? Now we'll see about the reaction with bases. So reaction with bases. Okay, now see, actually reaction with acids is most characteristic reaction of all metals, because metals are generally basic in nature and it is their nature to react with acids, right? But there are many metals which does not react with bases. There are only very few metals which can react with bases, and the metals which can react with bases are called as amphoteric. Okay, what do we call the metals which react with the bases? We call them as amphoteric metals, because the same metal can even react with the acid, right? So for that, one example we will take, that aluminium. See, aluminium, we already know that it can react with the acid. It can replace hydrogen from its compounds to form its corresponding chloride or bromide. Right, now the same we will take with base. So aluminium, if it reacts with base, it gives sodium aluminate. Okay, so this aluminium can react with acid as well as it can react with base also, and hence we call the aluminium as a amphoteric metal. Similarly, we can even take zinc also. Zinc also can react with sodium hydroxide and it gives sodium zincate, Na2ZnO2, again with the release of hydrogen. Right? So what are the compounds formed? If aluminum reacts with sodium hydroxide, it forms sodium aluminate. The name of this compound is sodium aluminate. Okay, and the name of this compound is sodium zincate. Okay, so from this there are very few metals which can react with bases, and those metals which can react with bases are called as amphoteric metals, and except those amphoteric metals, remaining most of the metals generally directly react with acids and release hydrogen. Have a look.